As Joshua mentioned, my name is Badal, and I'm the technical engineer with Bitnine and AgensGraph team. And some of my responsibilities in this team, I support AgensGraph, and also when it comes to the consultation, I always join and I answer the question that might come up.
So Aya, what would you like to speak about today?
So today we have a really interesting topic which came up in some of the questions with some of our clients that we have. So our today's topic is deeply nested data, specifically to the graph databases and graph modeling. So we will learn more about it together. So again, I just want to thank you all for joining us. And if you have any questions at the end of this webinar or anytime, you're more than welcome to reach out to me through this email, or you can also go on the Bitnine website and we have a contact us section. So please feel free to contact us anytime. So to get started, just an overview and the agenda of our today's webinar. We're going to do a quick introduction on Bitnine and also AgensGraph. Then we're going to deep dive to the deeply nested data, and we're going to specifically look through to see how we can handle it in a graph database. And also after that, we're going to look in more details in the AgensGraph approach. And as always, at the end of the webinar, Q&A is open. You can send your question through the chat box, and we'll be more than happy to answer your question. So please enjoy, and I hope you have a great time. Bitnine, to just a really quick overview, we have different locations all over the world. We are located, me and Joshua, we are located in San Francisco. And we have an office in New York. We have office and a team in London, UK, and also we have another team and office in Seoul, South Korea. So we are global, and we cover all those locations and also the other ones. So really quick about graph structure for some of you that are just new to this topic. As you can guess, graph structure represents vertex and edges, and the combination of this vertex and edges will create the graph structure. So for example, as you can see, we have one vertex here, and you can assume that this is a person vertex. So, and for example, his names in this example is Hein. And we have also another vertex in this graph, which can be any item, any purchasing or any shopping items. So what happens in a graph structure, we can connect our vertices through an edge, which you can see it here, and we can make relationship and we can make more meaning through this edge for our vertices. And by combination of vertices and edges, we have the graph structures. Graph databases. Graph database is a database that uses a graph model, which we just went through it, to store, manage, analyze, and represent the data. So everything is a combination of, as I mentioned, vertices and edges in a graph model, and graph database, we use it to represent that. And also graph databases, they have their own query language, which in our case, AgensGraph, we support Cypher. They have their constant time traversal in a big graph for both depth and breadth. Due to efficient representation of nodes and relationship comes constant time traversal. And also it comes flexibility when we talk about graph database, specifically when it comes to the graph schema, which is really easy and fast to adopt over time if any changes happen. Let's talk about some of the benefits and advantages of graph databases. So if we look at this specific examples, we have a specific query here. And in this query, we are looking to search for a friend of Alyssa. And as you know, when it comes to the relational databases, everything is stored and saved in the table format. In this example, again, specifically, we have a person table and we have person's friend table, and data are specific in these tables. So when it comes into this approach to relational databases structure, and if you look for this query, we know that we have to go through the join operations to get our results. Also, we know when it comes to the join operation, those operations are expensive operation, it's time consuming, and we need to basically spend more effort and time. But when it comes to the graph databases, you can simply avoid those join operations, and you can just follow the patterns. And for example, you can start from Alyssa. You can see who's Alyssa's connected it to, and if they are friend. And the same approach, you can see who is connected it to the Bob, and see if friend or not. So this way you can find the friend of Alyssa. And in this case, as you can see, the response time for graph databases was much better. It was much faster. And also, as we go deeper, we did more results. As you can see, the graph databases perform better. And also, the fifth level relational databases couldn't really perform. This is one of the advantages of graph databases in this case, which we would like to share with you. Really quick on AgensGraph as a solution. AgensGraph can support any data types from different sources. Those data can be science data, social network data, and as I mentioned, any type of data. So you can simply transfer all those data from different sources into AgensGraph and all in one storage in AgensGraph, and you can use our visualization tool, which is Agents Browser, and also some of our graph data analytic framework that our team provided. And what you can do, you can solve some of the graph database applications or some of the use cases that are out there, such as recommendation engine, such as master data management, fraud detection, and so on. Now let's take a look at this diagram. It's a really interesting diagram here. So as you can see, this diagram is mostly focusing and talking about the scalability when it comes to the size and also when it comes to the complexity. And you may also, most of you know, people tend to talk about relational databases more when it comes to the size. And at the same time, we know that relational databases have some trades-off when it comes to this concept, to the concept of the size and the scalability. So for this reason, document DB databases are used to the market. And also at the same time, we know that when it comes to the complexity, graph databases performance is better, and also it can perform better and faster. So by saying that, we can basically get results that if we have a multi-model database, we can support and cover and have a better performance when it comes to the size and also complexity. And AgensGraph as a multi-model database can offer you the better scalability when it comes to the complexity and also to the size. What I want to talk about it, we're going to go over some of the AgensGraph use cases. So the first use case that we can see here is our MDM use case, which is master data management. In this specific use case, some of the challenges that they were facing was lack of data standardization, which was leading to a different format and scattered storage in various systems. And also, they were lacking of a data model to view, modify, analyze, and visualize their data. So by using AgensGraph, they were able to solve and they were able to come up with a standardized data. And they were able to have all their data in one repository. And also, they construct and build a stable and flexible graph model. And also they were able to build a web portal that were supporting their visualization and their reporting system. Second use case that you can see here in the left side of this slide is our CTI use case, which stands for Cyber Threat Intelligence. In this specific use case, some of the challenges that they had was a continuous evolution of cyber attack. So they had limited performance of the table structure data for the processing and also for the analyzing their complex data. So the solution that they were able to achieve through AgensGraph, they were able to have an integrated relation analysis system. They were able to build a real-time monitoring system to visualize all their information that they were looking for. Our third use case, as you can see here, is our network management use case, which is really interesting use case. In this specific use case, some of the challenges that we had was the table structure. Data processing system had a really limited ability, and also their existing monitoring system was difficult to rapidly check for faulty equipment or conduct root cause analysis. AgensGraph, what they did, as you can see here in this right side of the slide, they established a database that can manage the related information, each equipment, same structure as the reality through graph data modeling. And also they were able to establish visualization platform to monitor and manage connection structure, location, and also the history of each equipment that they have in their network. Another use case that we have here in this slide are our performance management use case. In this specific use case, the challenges was it was a need for a system to manage collaboration efficiency, and also data. They had the data with different formats in multiple systems because of their type, and also it was difficult for common relational data models to quickly and process and analyze in that specific legacy system. So some of the solutions that they come up through AgensGraph, they were able to standardize the fragment data from each department and save it as a standardized graph data using AgensGraph. So they were able to implement the ability to view, manage, and analyze all those processes, and also the collaboration between different departments. Our next use case that we have here is our knowledge graph, also known as personalized education service. In this specific use case, there was a need to develop customized learning recommendation system, to develop different new education services or differentiated services, and also the challenges they were facing was the table structure data, which wasn't a really good solution for the recommendation and for this system. So the solution that they come up with, they build an organic learning graph model, which is known as a knowledge graph, through the AgensGraph, the graph part of it, and they were able to build a behavioral data analysis model to identify all these learning levels and learning patterns that each student had. These are some of the use cases of AgensGraph that I wanted to share today with you. And for the next, we're going to talk more about deeply nested data. So in this slide, we will take a deeper dive into the nature of nested data structure. We're going to see how they are represented in different graph databases. Also, we're going to go over some of the benefits and also challenges of using this nested data structure. And finally, at the end of this section, we're going to propose an approach that addresses some of the challenges of having deeply nested data in graph databases. So to get started, let's see what is deeply nested data. So I know I talked a lot about this topic, but now let's just see what is it. So in general, not thinking about data, deeply nested is something that is nested and is fully contained within something else of the same kind. So as you saw in my previous slides, I had those Russian dolls. So they were all nested to each other, but they were all at the same kind. So you can think about that. So it's the same. When it comes to the data, when talking about the nested data, we're specifically referring to a single or a group of variables that are associated with a particular group and signify an important observation pertaining to that group. That's the meaning when it comes to the nested data. And also one of the famous and well-known examples of this structure of this nested data is a JSON data, which most of us are familiar with it and probably worked with it before. Now, when it comes to the nested data and graph, in the past few years, there has been a subtle but significant shift in the way that data is structured in the database. Whereas yesterday databases were typically limited to storing data in rows and tables, today's modern databases, such as graph databases, often could make use of nested data structure, especially when it comes to the nested data properties. However, as I mentioned, if the graph databases work, the deeply nested data could also be a challenge. But luckily, some of graph databases such as AgensGraph support this deeply nested data as a property. So it's because it supports, it's making it really easy to work with this databases and use the advantages and benefit of this nested data, which we're gonna look and go through it together in this webinar. So let's take a look at some of the advantages that this deeply nested data can offer us. So one of them is that by using this data, we can reduce the amount of pre-processing operation while modeling our data. As you know, this deeply nested data have different depth, all nested together. So by having a graph database that can support this structure as it is and as its original structure, we can avoid some of the processes such as dividing this data to the separated and independent one. So we can just grab the original structure and we can move it to our property of our graph or vertex. Another advantage is it simplifies the data structure. So you can, as I mentioned, just have the original structure and put it there, and that's it. Another advantage is that they reduce the storage cost. And as you know, it's a crucial aspect when it comes to the storing data. Another advantage is that I have here, having nested data can reduce the amount of pre-processing when you want to query your data or you want to analyze your data. And again, that's because you don't need to change or modify the structure even when it comes to the querying. You can just simply query specific depth and specific property that you are looking for when it comes to the deeply nested data. Okay, now for specific topic, this is one of the graph model that we're gonna look through it today to see how deeply nested data can represent in a graph model. So as you can see, this is a flight graph model. It's a really simple model, and as you can see, we have two vertices. We have one edge, which is relationship. So we have passenger, we have flight, and we have a relationship book. So passenger has its own properties, and also flight vertex has its own properties. But for today's session, we're going to mostly focus on the properties of our flight vertex, which are the nested data. And these are all the JSON format, which we're going to go in more detail in my next slide for it. So as I mentioned, this is a JSON structure, and these are our flight properties. So if you want to look at it a little bit more closely, we can see that we have a flight number here, we have a date here, we have also time here. And as we go deeper, you can see that in our destination address data, we have different depth. So we have a city, we have location. At the next step, we have area, we have geolocation at the next step. And again, we are going more deeper. We have latitude and longitude in this case. And also we have another property, origin address. It has the same depth with the destination address. We have a city, location, area. It goes more deeper. We have geolocation, latitude, and longitude. And also some of other properties that we have here. We have rows, we have elements. We go more deeper in the next step. We have distance, and we have some values. We have the duration of the flight, and again, a little bit deeper, we have, as you can see, a specific time of the travel, and also other values. So these are the data that we're going to work today with it. But again, as we want to focus on a specific part of this data, we're going to mostly focus on the destination address property in this specific example. So if you go here, you can see that this is the destination address, which we're going to focus more onto it. Just really one more time, really quickly about this property. We have a destination address. This destination address contains of city. Then next level, we have location, we have area, and also in the next step, we have our geolocation, latitude and longitude. And what we're gonna look through, how we can model this as a property of the flight vertex. At the beginning, we're gonna focus and we're gonna see how this modeling happened in one of the graph databases in the market. So this is a different graph database, and we just want to see what are the challenges and what are the maybe approaches that we can have in this model. So this is the query that we used here. So we try to create a flight vertex with this properties, with this data that I showed you before. So this is the same structure. We have a destination address, we have city, we have location, we have next depth, area, and we have our geolocation. So after running this query, what happened, we got an error here. And this is because this specific database, graph database, does not support the plain nested data. And as you can see, the error was the property values can only be of primitive type or array therefore. So again, it didn't support it. So what we're gonna look through, what we wanna do in this webinar, we will look through some of the workarounds that we can have to overcome this challenge. Before we go deeper to this workarounds, I just want to say that this workarounds might not be the best practice. So we just wanted to show you to how overcome the challenge. It's good to think about some of maybe other alternatives as well. So we go to our first workarounds. In this first approach, we are looking to have independent and separated properties instead of having deeply nested properties. So by saying that, I mean that instead of having them all nested, what we did here in this workaround, we just separated them as independent properties. So we have our destination address, then we comma separated, we have our area, then again comma separated, we have our latitude and longitude. So as you can see in this query, we don't have our original structure. basically the data are not structuralized anymore, and they are not nested. So if you're looking to have and keep the original structure, this is not the approach for you. This is not the workaround that you're looking for, but it may just overcome the challenge, and you can avoid that error. So as you can see, by running this query, after that we added one label, we created one node, and we set 4 properties instead of 1 properties that we were aiming for at the beginning. And what working on this workaround, my manager just come up with another idea, and we thought about having these properties as an array, and to basically solve this problem. But what happens, as you can see, after creating this query, and after having these values here, and also we had like array of array. So as you can see, it's you can think about it as a 2D arrays. As you can see, we only have values here. So again, we are losing the original meaning of the data. So we are missing our keys in this case. So our next approach in this case is to have JSON data to be serialized, so we can use them as a property of our vertex. So basically what we can do, we will have all nested properties with the same structure by serializing them into the cipher string. And after that, just push them through the vertex or the node that we have in this case, which is flight number. And after doing that, what happens, all that data, all that JSON data will be counted as one normal string. So, and as you can see here, this is what I mean. So we only have this red quotations here, if you can see it. We're only gonna have one normal big string at the end of running this query. And so what happens, if you want to query this data, you need to go through one more step, and you need to deserialize this string. And the reason is that because you are when you are retrieving or data, you do not that if this is one normal string or if this is a JSON data. What you need, again, you need to basically deserialize the properties to the native object so you can understand it better. And also, this is because if you have it all as a one string, you cannot access a specific property while querying it. So if you query it, all the data will come back as a one structure, and you will lose the ability of accessing specific properties in one place. And also, this approach can be achieved in functions. But again, you need to keep in mind some of the downsides to this approach is that we are adding more steps to our process. If you want to write the function, again, it's extra steps, and then through that function, we have to serialize, and again, we have to deserialize our data just to have it model in a graph and just to query it. So yeah, again, this is one of the workarounds, but you need to think about it that it will add more steps to your process. Another approach that we have here is to have the properties that we're looking for in the relationship that we have. In this case, our edge, our relationship booked, as you can see. And what we did, we just grabbed some of the properties, we model it in that edge as a property of that edge. So again, this is not the main idea. This is not what we're looking for, but again, can be a solution if you really wanted to solve this problem. And as you can see, we don't have all the data, so some of the data you can keep it in the flight again, but in this case, you are getting far from the main idea. It doesn't really make sense to have the properties of the flight vertex in a relationship. So what if flight information changed, then that very specific vertex needs to be affected, not the specific relationship to that flight. So these are some of the elements and facts that you need to keep in mind when using some of these workarounds, and that's why I mentioned it at the beginning, some of them are not the best practices. Now, the next approach or the workaround that we have here, it's to have additional vertexes. By saying that, as you can see in the query that we have, we added vertexes such as location and also geolocation. So basically, we separated those properties. Instead of having it as a property, now we have it as a vertex. And what happened, as you may already notice, when it comes to the new vertexes, also comes new relationships. So as you can see, we have destination and also we have has as a new relationship to our vertexes. And again, this is not the main idea. And also at the same time, if you notice, it's adding the more steps to our process. And also you need to keep in mind that querying this model and this structure may need a little bit more effort because you're adding more degrees and you're adding more levels to your graph model. And you have more hops now. So if you want to query it, you need to go through more relationship and more vertexes. Our next approach is adding basically additional databases while working with the specific graph database that you're facing a challenge in it. So these graph databases are all supporting the deeply nested data structure. So some of them can some of the famous databases to use can be MongoDB, PostgreSQL, or also Amazon S3. So what happens in this approach, what you can do, you can have your normal data, not nested ones, saved in the graph database. And when it comes to nested data as a property, what you can do, you can save it in this like additional database or different databases. And you can save the URL pointing to those databases in your graph database, which will point to that basically MongoDB or PostgreSQL, and you can access your deeply nested data. Basically, you are getting the benefit of using DB or the databases that are supporting JSON data, and you're going to use a combination of this graph database and also the other database at the same time. Again, it has benefits and disadvantages when it comes to this approach. So yes, the benefit is that you can make it work and you can have both data. But some of the disadvantages when it comes to adding a new database, as you know, it's additional cost, and also it's the cost and it's the time when it comes to the integration of these different softwares. And also, you need to keep in mind that when it comes to the two different separated software or databases, network traffic also is an element, that's also is a fact that you need to keep in mind, because it might be some traffic when you're working with the different databases. Next, we're gonna take a look at AgensGraph approach when it comes to the deeply nested data. AgensGraph uses this PostgreSQL JSON B type. For this reason, when it comes to the deeply nested properties or deeply nested data, AgensGraph can support it with no problem, and you can just easily grab those deeply nested data, and you can have it as a property of your vertex or also as a property of your edge. And you don't need to go through any additional process or any additional writing the code or anything. And And as you can see it here, this is AgensGraph, and as I mentioned, because AgensGraph supports JSON type of Postgres. So just really quick go back and on the error that you saw at the beginning of this webinar. This was the query that we were aiming to run, and we got an error. So what we're gonna do now, I want to show it to you to how to run the same query in AgensGraph. And for this reason, I'm gonna do a quick hands-on session so we can do it together, and you can see what happens if we have deeply nested data in AgensGraph. If you just give me a couple seconds, I'm just switch my platforms, and we're gonna go to AgensGraph environment here. So this is our CLI, and I already prepared some queries so we can make this a little bit maybe more efficient. So we're gonna start from scratch, and what I wanted to show you, we're gonna start creating our labels, which is flight, passengers, or vertexes. And we're gonna create our e-label booked, which at the end we can have the structure that we looked. So for this, just quickly gonna create a graph here. So create graph, we can call it flight. And we're gonna set our graph path in this case the flight. You can see that we're starting from scratch. Okay, now we can just simply graph this create, and there you go. So as you can see, we created our labels. We have our flight, we have our passengers, and if I run this, we will have our booked relationship here. So our data are here, and next what we're looking for, this is the same query that we ran in a different graph database and we got an error. Now we're going to try it in AgensGraph, but really to just overview it one more time. We have a destination address, we have a location, in the next step we have area, and we have geolocation. We're going more deeper, we have latitude and longitude in this case. Now, let's say how AgensGraph will perform. So by running this, there you go. You can see that we are simply just made our vertex in this case with the same properties as you can see here. One vertex is already inserted. Now, let's go a little bit more deeper. For this exercise, I just created another vertex for the passenger. And I added some deeply nested data again as a property. So as you can see, we have a passenger here, its ID, its name, which goes into depth. We have phone, work, home, cell phone. It goes a little bit more deeper with the area code and number, and also address, which is again have different depths to it. So by running this query, as you can see, our vertex is created here as well. So with no problem, we have our nested properties and two vertices that we just created, flight and the passengers. And next, what I would like to do, I would like to make a relationship, to make a connection between these two vertices, so you can see the same structure. As you remember, we had the booked edge between these two vertices. So in this case, what I'm aiming to do, I'm aiming to make a relationship between the flight and the passenger with a specific condition. So I'm looking to have a flight which is destination address is Philadelphia, and also I'm looking to make a connection with a person who his first name is John. So my point here was to show you to even you can achieve and you can access deeply nested properties when you're creating an edge and while in the condition. Use this also when it comes to the condition and making relationship. So we're gonna copy and paste this here. And there you go. As you can see, we already inserted one edge, and our relationship is already made. Now, really quickly, we can query some of this data to make sure that everything is there and we can see it. And for this reason, we're going to go to our visualization tool, and which is Agents Browser, and we're going to see that if our data is there or not. And there you go. This is our schema. As you can see, we have passenger, and also we have a flight, and this is the relationship that we made. Now, to see our data, we can move on to the graph section, and we go back here. So the first I would like to run here is we are looking to return flight and its destination address. So as you can see, destination address was here. It was the first step. So we're going to start with that, and we're going to move on to see how we can access our. So I'm just going to run this one more time. And our result will be in a table format. So as you can see, it's the same data that we were aiming for. This is Philadelphia, USA. The next query, we're going to go a little bit more deeper. We're going to go to the area section, and we're going to see how we can achieve this property. And again, we go to the table, and there you go. This is our south, basically, data property that we had. Now, to just make sure that we can achieve more levels, we can go to the geolocation. We can see if we can achieve this. And there you go. These are all geolocation. Again, geolocation has more depth to it. It has latitude and longitude. Just one more time to make sure we can achieve another depth as well. The next level, we can aim for latitude in this case. So we go here, we copy this. As you can see in this query, we are going through the geolocation. We are going through the location at the beginning. Then we're going another depth. We're going geolocation. Next step, going to the latitude. So by running this, we go here. We run this, and to make sure that we have the data, there you go. So we have our data. This is the latitude, as I mentioned. So as you can see, we can simply achieve any level of the nested data properties in this case. And also, at the same time, you can create, but at the same time, you can access this while in the condition of your match query. So in this case, you are looking for a passenger and the flight, and we are looking for the location, which is south, and also for the person, which is cell phone number has an area code of 408. So as you can see, this is a 3 level. We are looking for the phone, cell phone, and then specific area code, which is 408 in this case. By running this, we can go here, and if we run this query, there you go. We can see these are our data. So this is a passenger, and I'm just going to make a different color maybe, and this is a flight. Also, one more thing to make sure that we have the properties. If we click on the specific vertex, you can see that all the nested properties also showing here as the same way it was. And also for the flight, we have the same structure, same levels, same original model. So everything, you can simply access it, you can easily query it, analyze it, and this is AgensGraph supports all the deeply nested data. And that would be all. Thank you all for watching. Now, our next session is our Q&A. So please, if you haven't sent any question yet, you're more than welcome. You have a couple minutes to send your question through the chat box. And if you just give me a couple seconds, I'll look through to see if we have any question to answer. Okay, so I do have the first question here. The question that I got here is that can we use or can we have different data types in our nested data properties when it comes to modeling it? So yes, the question is yes. As you saw, even in my example, I had different data type. We had numbers for the latitude and longitude, and also we had string data type for the names, or I believe we had for address or destination addresses as well. So yes, to just make it quick, the answer is yes. Another great question that I have here is that can we use this approach while we are creating and using the hybrid approach of AgensGraph and while querying SQL and Cypher? So the answer again is yes, as you already mentioned in the question. AgensGraph supports hybrid query, and for this reason, yes, you can also use this nested data property while creating and while running hybrid queries and using hybrid approach in AgensGraph. And it's the same process, it's the same basically approach. So yes. Okay. So again, thank you for watching, and as I mentioned, you are more than welcome to reach out to us if you have any question. And again, thanks for being here. Hope you all have a great day.